this video, we'll discuss tutorial 1 and tutorial 2 questions together because they are somewhat linked, and to also prove to you that let's say you have a stress tensor over here, right? This, if you remember, these three are the normal stresses. If happen that one of the normal stresses becomes 0, you're gonna change the von Mises stresses, and you're gonna make the von Mises stresses to increase. Alright, so we're gonna prove to you that when there's one normal stresses becomes 0, your von Mises stresses is gonna increase to a certain extent. Alright, so let's do it. So therefore, the first question it asks it's not first question, but rather than this whole thing is question 1. In fact, alright, this whole thing is question 1. So the first task they want you to find is actually to find the principal stress. One of it is 300 MPa. And therefore, once you talk about principal stress, the first thing you'll know is this is your stress tensor, describes your stress state. And definitely you need to find your principal stresses. Alright, this is Ij, alright, if that's the case. So do not mix this with this one. This is just the principal stress. Normally is 1, normally is sigma 1, sigma 2, and sigma 3. Alright, so this is the equation that you're going to use, and you're going to find your I1, I2, and I3. Alright, and these are the I's that you need to use. Alright, remember that we're talking about stress state. Alright, when you're given this stress state, alright, and you're asked to find the principal stress, then you use this formula, sigma 1 1, sigma 2 2. Alright, if you're however given as if you are given a principal stress, alright, it's already given to you some numbers, alright, then they want you to find invariance, then you shouldn't use this formula anymore, alright, because the one that we've been using later on is actually this one, right? That's what I crop out, is 1 1, alright. However, if you still remember back, there is also another form of the stress invariant formula, alright, that talks about stress 1, stress 2, and stress 3. So these are all the stresses for your principal stress. So you already know your principal stress, and they ask you to find the invariant. So in other words, they will not give you this one. Alright, in other words, they actually will not give you these things. They'll give you some numbers over here and say that these are the principal stress, and find your invariance. Then you use that formula. Alright, repeat again, you should not use this, you should not use this one. Alright, this sigma 1, sigma 2, and sigma 3. These are minus sigma 1, sigma 2. If you were to compare, they are actually two different formulas. Alright, although this one is the same, but please do not cop out with this one. They're actually not the same, you see, it's a long chunk. So be very careful of this, and this is the awareness that I want to make before I start on. Alright, because it's straightforward for this question. Let's go. So just name this in case that you may forgot. Alright, sigma 1, sigma 1, 2, sigma 1, 3, all this stuff, I'll just name it over here. So as to when you sub in, at least it's easier for us to see. Alright, so I sub in into I1, sigma 1, 1, sigma 2, 2, and sigma 3, 3, which is 300 plus 100 plus 300. Alright, therefore it's equals to 700. So it's just summing up this one over here for I1. Okay, then as for this one, sigma 1 1 times sigma 2 2 is actually sigma 1 1 multiplied by sigma 2 2. You'll get a certain value over here, 300 times 100, and then plus sigma 1 1 times sigma 3 3, which is this one, times sigma 3 3, and the rest should follow up. Alright, you just put in and sub in, and you should get the values. Okay, once you sub in for all the stuff, I1, I2, I3, what you have is these values here. Alright, 700, 100,000, and minus 6 times 10 to the power of 6. So now I have my I1, I2, I3. I'll just simply sub it into all this stuff. Alright, what I have is this is your I1, your I2, and I3. I'll just simply sub it in. You can double check with this formula. So I'll just take a look. Alright, just compare with the numbers. Important thing is that you have to take note of the negative sign or the plus sign. Alright, and over here is negative, plus, negative. Alright, so I have a negative, plus, negative, but please take note that we have a negative 6 over here, right? This is coming from here, so I need to negative will become positive. Alright, and then I'll just remove away this stuff over here. Alright, and then this is our quadratic equation. It's a cubic equation, I would say, not quadratic. Alright, so you just type in the calculator. I would have 3 values over here. Alright, and this is a nice number because it corresponds to the one that is given from the question. So therefore this proves that we are safe. Our numbers is actually correct. What we have done by subbing in all this stuff is proved to be worth some money. Alright, and therefore this is our principal stress. But how do we write it in matrix? Alright, we know that sigma 1 is the largest of the values of all, which is 444.95. So to sub it in as this one. Sigma 3, alright, which is over here, alright, is the smallest number that we need. So I have to sub it in. And the in between is definitely 300, where the rest are 0. And that's it. This is your principal stress. Okay, so we haven't finished yet. This is just only the first task. The second task is to find the von Mises stress. How do we find the von Mises stress? You can assess it through these lights. This is your thick and thin wall stuff. Or if you were to all the way scroll down, you will have this thing over here. So I'll be taking this thing. Alright, so hold on. I'll just paste it over here. Alright, this is just applying the formula. We don't even know what is von Mises stress. Good job. Anyway, so now we have sigma 1, we have sigma 2, and we have sigma 3. Okay, so just simply sub it in also. Alright, but be careful of your negative sign. Alright, there's a negative over here. Please be very careful when you sub it in. Alright, so when I sub in already, verify this part of the equation. Alright, it's 616.44. Alright, so 616.44 divided by square root 2, because you're multiplying with 1 divided by square root 2. And therefore, if you were to have that, you have 435.89 megapascal. Okay, so this is your von Mises stress, your your sigma n. And therefore the answer for the question 1 is this principal stress and your von Mises stress. Alright, but we haven't finished of this video is because we are going to talk about question 2. Alright, with the same particular stress state, but instead of sigma 22 being 100, it becomes 0. Alright, so we're going to do with terms of this question and see how it goes. Alright, question 2 is the same thing. This is question 2 now. Alright, and this one becomes 0. Alright, they'll call you to ask you to find principal stress. One of it is given also as 300, just now also given as 300. So we will use this thing as our gauge to see whether our finding is correct. Then we find our von Mises stress and things like that. Alright, for our case, since we know sigma 22 is equals to 0, and we know this formula exists, this all the same, you know how to plug in already. I'll just simply cancel all of the sigma 22. Alright, if this is 0, this whole thing will become 0. If this is 0, sigma 22 is 0, right? Everything becomes 0. Alright, so this is for easy sake of calculation. Alright, this is 0, and then I have this one to 0 because sigma 22 over here also, so everything is 0 over here. Alright, so I've cancelled and removed the sigma 22 from our side. So I'll just simply calculate the rest of our stuff. Alright, what do I have is, just solving what I will have is these values over here, my I1, I2, and what is it, I3. Alright, but I just want you to take note is that be careful of sigma 11 times sigma 23 square. Alright, don't take it like that. Alright, it's not bracket the whole thing square, okay? So it's something that, just take note of, unless, certain careless mistake may occur. But anyway, so this portion over here is this portion, just to take note if you are calculating. If next time you just check it out, and then this portion is simply 0. Alright, that's all I flag over here, and this is totally minus 15 times 10 to the negative 6. So just simply sub in into this equation. So what I will have is and in fact I actually have a mistake over here. It should be plus 6. Alright, it should be 10 to the power of 6. I don't know why I go and put negative 6, but anyway, it should be like that. Alright, so now we have this thing over here. This is my I1, my I2, and my I3. Okay, just reflecting over here, you can just take a look. I didn't cheat your feeling. Okay, but take note of the negative sign again. Alright, the negative sign, which is negative will become positive, so I'll just have to remove it. Okay, so just be careful of the negative and the plus signs. Alright, be very careful. So now I just type into my calculator. I have 3 values of sigma. Alright, and we see this 300, we are safe. It's because in the question itself, one of it is 300. So therefore this can reflect that we are actually on a safe path. Alright, and therefore what can we do now? Write our principal stress over here. Alright, the largest number is always sigma 1. Okay, the smallest number is always minus 119 always the smallest, and in between is definitely this dude over here. The rest 0, because it's just principal stress. Alright, so therefore my sigma 1, sigma 2 and sigma 3. Okay, these are my principal stress. Now we're gonna do in terms of the volumetric stress. Alright, this is the formula that is given for your volumetric stress. Alright, if you can see it's sigma m over here. Alright, then I'll just sub in sigma 1, sigma 2. Alright, sigma 1 is actually this one if I didn't explicitly define in the previous part. Alright, where we solve for the this stuff. Alright, this is actually also sigma 1, this is sigma 2, this is sigma 3. This is for question 1. Alright, if I happen that I forgot to tell you, now this is it. Alright, so when I sub in my sigma 1, sigma 2, sigma 3, it's just simply subbing in. When I sub in, I'll have this value over here. This is my volumetric stress. But be careful over this part. Alright, sigma 2, alright, it's 300. It's minus 119. So add up together, so it's 419.26. This is something of the sign you have to be very careful. But anyway, you'll still get back this as a volumetric stress. And therefore, let's compare. Alright, in fact, we have this solved for question 2. Alright, but let's just see the results. As you can see, for question 1, alright, we actually use this stress state to find our principal stress, and these are the stuff. And then these are the volumetrics. For question 2, this becomes 0 at the middle. So there will be one normal stress that is 0. And therefore, as you can see, for question 1 now, the volumetric stress, if three normal stresses exist, alright, meaning if you have a cube over here, if 3 normal stresses all exist, alright, within the stress state itself, as you can see, they have some values, your volumetric stress is actually somewhat below your stress 1, or your ultimate, or your maximum tensile stress, I would say. Alright, maximum tensile stress, this is maximum compressive stress. So your volumetric stress is actually kept bounded below the tensile stress. Alright, but once you remove one of the normal stresses, alright, this is maybe this, once you remove this, alright, so the rest of the stresses actually, so I remove this as 0, the rest of the stresses like sigma 1, 2, sigma 2, 1 and stuff, the shear stresses actually try to so-called deform your stuff already in this direction. Alright, so you may have something like that, alright, something deformed. So therefore, the volumetric stress actually increase and shoots up to larger than your tensile stress, because your volumetric stress somewhat relates to the shear stress. I don't know why, but just take it first. So therefore, as you can see, this is the result. Alright, and therefore this is kind of like there. Apparently the middle didn't actually change. Alright, so I don't know why the middle values didn't change, but something you may want to take note. Maybe in the future you may come across and just leave a comment over here. So yeah, see you soon.